All right, so we're just going to do 4 examples here just to keep our minds going with U substitution. Okay, so let's work through our routine here. Number 1, what's U? X squared plus 1. What is du? 2x.
2x squared. Well, 2x squared
dx. Okay, 2x dx. And I'm making a point of that because the people who don't write down the dx end up getting confused typically later on once we do substitution. Okay, so we're substituting because that's a 2x dx. There's the 2x dx right there. So that's the du. Okay, and then the x squared plus 1 is right there, that's the u, so this is u squared. So we're doing the integral of u squared du, and you know the integral of u squared is u cubed over 3. So we want the answer with respect to x, so this is going to be x squared plus 1 cubed over 3 plus c. Okay?
What happened to the du?
When you take the integral, the du is that differential. Okay? It's just like the integral sign. It's part of the thing, and when you take the integral, it's gone.
Oh, so that would be like the dx in this situation?
Yeah. Yeah. Okay? Let's try another one. Okay? What is u in this case? 5x. We'll just do the 5x. That is inside the cosine. And then what is the du then? 5 dx. Alright, so the du is right here. I'm replacing that. Okay? And I'm taking the integral of the cosine of the u. The u is the 5x. Okay? Now we know our antiderivative rules. What's the integral of cosine? Sine. Okay, so this is sine of u. Put the u back in. It's sine of 5x plus the c. Okay?
Do you not do 5x squared over 2?
No, we're not taking the integral of the 5x. You're just taking the integral of sine of something. The integral of sine is cosine. You remember our sine, cosine, negative cosine. Clockwise is the derivative. Counterclockwise is the integral. Okay. All right. Oh, here's an interesting one. Okay. What's the u? 3x? Question mark? Let's try it. And this is where you just have to try stuff, okay? So the du would equal what? 3dx. Okay? Now, the 3dx, I've got the dx. I don't have a 3, so I'd have to put a 3 here and put a 1/3 out here, right? Remember doing that from me yesterday? Okay? So there's my du. So let's write what we've got so far.
We didn't do this. We had a test yesterday.
Oh. Yeah. Yeah. All right, so if you're missing the du, if you're missing part of the du, you got to insert it in there. And here, remember what we're doing is the rule that for a constant multiple. If we have the integral of c times f of x dx, we can rewrite that as c times the integral of f of x dx. Now what I'm doing here, I didn't start with the constant, but what I'm actually doing is What's the number we're allowed to multiply by whenever we feel like it?
The constant. Well,
You can't just multiply by 2 or multiply by 5 whenever you feel like it, but we can multiply by 1. So I'm going to multiply by 2 over 2. I only need the 2 on the inside, so I put the over 2 on the outside and leave the numerator on the inside. And I'm using that property just with the form of 1. Okay? So there's my du.
Why do I need to be 3?
Yeah, 3 and 3, sorry. Got sidetracked there. 3 and 3. We can multiply by 2 over 2, but it won't help. Alright, so 3, and there's our third. Okay, so we're trying this, and we substitute in, now that we've done that, we substitute in the u's. There's a u, there's a u, and we look at what we have. We have the integral of sine squared u times cosine u du. Now, am I able to take the integral of that? Or the antiderivative of that?
yes.
You have to split up signs.
It's like- Well, there's a sine squared, so you have to do another
Can you
subdivision.
just do 2 signs?
Okay, we would have to do like u substitution again, potentially, because here we have another inner function. Okay, so let's actually do it. I'll make it a v. Okay, so we don't want to use u twice. Alright, so I'm going to make the inner function my sine of u. So what's dv? What's the derivative of sine of u?
Cosine.
Cosine u du. Okay? So now if I do substitution again, I have 1/3 times the integral of v squared. And notice here, cosine u du is right here. So that right there is just dv. Okay? Now what's the integral of v squared?
V cubed over 3.
V cubed over 3. So I have 1/3 times v cubed over 3. So that's v cubed over 9. But I don't want my answer in terms of v. I want it in terms of x. So now we kind of have to start going backwards. V is the sine of u. So this is sine of u that's being cubed over 9. But again, I don't want my answer in terms of u, I want it in terms of x. So, what was u? U is 3x. So this is going to be the sine cubed of 3x all over 9 plus c. Okay, so there we had like a double u substitution. Double u substitution. Totally confuse us. Now, there is a little bit of an easier way. Okay, if we had recognized the function in a function right off the bat, let me change colors here and we can do this a little bit differently. Okay, if in the first place, I'm going to do this a second time. If in the first place I had had the integral of sine squared of 3x times cosine 3x dx, and I had let u equal the sine of 3x, okay, my du, I'd have to use the chain rule, but it would have been cosine x, or sorry, cosine of 3x times 3, chain rule, du, okay? Now, this would have been the whole du, or sorry, that was a dx at the end. Should be a dx. Okay? Well, I have the dx, I have the cosine of 3x, the only thing I'd be missing was the 3, so I'd still have to do this 1/3 and 3 thing. Okay? But notice what I have at this point is I would rewrite this as, as 1/3 times the integral of sine of 3x is being squared. Well, sine of 3x is u, so that's a u squared. The rest of that stuff in there is the du. Okay, so that's where I have 1/3 times u cubed over 3. If I plug the u back in, this time u is sine of 3x. That is being cubed. It's all over 9, and I have a plus c. I got the same thing. The reason why it worked to just do u as sine of 3x is because I was able to get everything I needed. Okay? And especially because this 3x, when I took the derivative, it was just a constant, so that was easy to work out. Okay? So that's a little bit more complicated of one, but notice you can do multiple u substitutions, or sometimes the u can be a composite function itself. Alright, so that's how we would handle composite functions that are more than one composite. Okay, in the chain rule we had to do a chain within a chain. For derivatives here we might have to do u substitution inside of a u substitution and just keep back substituting to get our final answer. Okay? Alright, one last example, something else that we might run into, okay? What would the u equal in this case?
2x minus 1.
Yeah, let's try the 2x minus 1. Okay? Now the du would equal what?
2x dx. Or, oh wait, no. 2x squared.
You're integrating. I know. Just the 2 dx. Just a 2 dx. Yeah, every one of us, including me, at some point through this unit, especially as we're making the transition from derivatives to integrals, is going to be mixing up the rules at some point. So, we look at this, we get a 2 dx. I've got the dx here. I'm missing the 2, so I put the half outside. And here's my u. So I substitute. And this one throws another little wrinkle at us because I have the square root of u and I've got the du, but there's this extra x in here. And no, there's no way to integrate it if we have an x and a u. We have different variables mixed in there. Okay? Does anyone have an idea of how we could handle this though?
Yeah.
Sunny?
Make the x in terms of u.
Alright, and how would we do that?
Use the u to
Yeah, let's use the u that we have, and I'm going to make this u plus 1 equals 2x, and that means x is 1/2 u plus 1/2. Now, will this always work? No. Sometimes, even after we do this, we'll get stuff that you still can't integrate. But in this case, the nice thing is we have 1/2 integral, and I'm actually going to rewrite this as a 1/2 times u plus 1. Okay? So I have a 1/2 times u plus 1 times the radical u du. Okay? And I rewrote it that way because I'm going to pull the other half out of here. So now it's a 1/4. And then notice the reason why this one will work is because even though I still have things multiplied and there's no product rule for integration, I get something that I am actually able to distribute and get into something I can take the antiderivative of. Alright, so u times radical u is u to the 1.5 power plus the radical u. And now we have stuff we're able to use that power rule for. So I've got a 1/4. It's going to be u to the 5/2 times 2/5 plus u to the 3/2 times a 2/3. I just distribute my 4 in, and I've got u to the 5/2 over 10 plus a u to the 3/2 over 6. The 4 cancels out the 2's. Alright, final answer gotta be in terms of x, so now I just put my 2x minus 1 back in. And I don't forget the plus c. Alright? Now, if you can handle that, that's gonna be about as complicated as it gets. Okay? These ones where you have to actually solve the u for x and substitute it in after doing the original substitution because you have leftover pieces in there. But that's how we would handle that. Okay?